Hi everyone, it's Alex with Wide Awake Travels. Today is a big day because I'm starting to do the house wiring in the bus. The wire I got was this Anchor Marine Grade 12-2. It's flat, it's tinned copper, it's flexible, like it's not solid core, it's stranded. That way when it's vibrating when I'm driving, it's not gonna get damaged like Romex might. The cheapest I can find was on eBay, so that's what I'm gonna start using now. I just have to think of everything and all the appliances and all the things that are gonna run on DC and not forget anything. I marked on the floor with a marker kind of where the walls are, where the other stuff is, like water tank and all that stuff, so I can run the wires, rough it out and run the wires to those places. I decided to buy 12 gauge wire for everything because it's much easier that way. 12 gauge is gonna satisfy the requirements for all the appliances. For some of them it's gonna be overkill, but it's fine. It's easier for me to do that than go calculate the lengths, look at the power usage of each device, and then figure out what gauge wire I can use. So then I would have to buy multiple different gauges of wires. By getting 12 gauge, I know I can satisfy everything. Even for the AC side, the 12-3 wire, 12 gauge was gonna satisfy everything I need to run. So that's just a simpler way. It's probably gonna cost more getting the 12 gauge for everything instead of, you know, some 12, some 14, some 16 or whatever. But it's just easier for me. You know, I found a 100-foot roll of the 12-3 on eBay for $107 total. I'm gonna start out here in the front by the entrance door. Over here we're gonna have several switches. One is gonna be for the lights right above the dining room area, and another one is in the kitchen area. And then for that hallway between the kitchen and our bedroom and where the bunk beds are and the bathroom entrance, that's going to be a different switch closer to the back side. And then I also probably need to add a switch here for the outside lights that are going to be somewhere out here on the other side above the door or above the windows there on the outside, so when we are sitting outside we can turn them on. So I'm gonna need basically 3 light switches here right by the door, and I also want an outlet over here, 120 volt AC outlet, but I'll deal with the AC side later. I'm doing the DC first, so I need the DC switches here, and I need to run them all the way to the back because the back is where I'm gonna have the batteries, inverter, and, you know, fuse boxes. Everything is gonna be in this area over here. So I need to run that just like I ran these lights. These are the turn signal cable when I rewire those. Okay, so I took the end of the cable, and I know it's gonna be coming out here around the door, and here I'm gonna have a dividing wall that's gonna be for the back area. Is gonna be a small garage, so the wires are gonna go into that wall. I'm gonna drill the holes into the framing, so I gotta put this in here and give it enough slacks so I can, you know, wherever I decide to put the fuse panel, I will have enough to move this and connect it to the fuse panel, because I think I'm gonna have the batteries underneath, and then on this side of the wall probably I'm gonna have the inverter, fuse panel, fuse boxes, and charge controllers and all that. It's gonna be like in a box here, and I'm gonna have an access door. So I gotta give it enough slack here. I'm gonna have it over here. I'm gonna tie all this eventually with this cable ties with a screw, like I did this one. I'm gonna show you what I've done so far. So I thought of this method. Since I have DC 24 volt, DC 12 volt appliances, and then the 120 volt AC, you know, I need to run different lines for them, of course. I'm currently doing 24 volt DC, and I'm bringing the power basically from the fuse box, the battery. Power is coming into a switch, like let's say it's a light switch. I'm bringing the power there to a light switch that's gonna be here, for example. And then I'm running the line from that switch to the lights. But I'm also sharing the same line for, let's say, the lights, the power for the lights. I'm extending it to use it for the surveillance camera that I'll be using. So that one will also run on 24 volts, and I actually have a USB, small little USB converter that converts from 24 volts to 5 volts. That's gonna be in the wall where the camera is connected. So I can run it off of 24 volts really. And I don't need to have like a long USB cable, it'll be just short one to that little converter. So I'm running the surveillance cameras and one exterior light and like half of the interior lights that are up front in the bus. I'm running that all on this line. And I'm writing on the end of both ends of the cable what it's for. If it's a power, that means it's bringing the power for those appliances. And then if I put a switch, that means that cable is going from the switch to the light itself. That's how I differentiate between the two types of cables. And I'm putting 24 volts. I'll put 20 volts and 120 so I differentiate between different voltages. So I'm running this cable, for example, is coming all the way back from the battery, from the fuse box. It's gonna be meeting here in a light switch. Then out of it, I'm going back to the lights in the ceiling. And then I'm also extending the power out here so it goes to the outside light and the camera. And then from there, I'm also basically daisy chaining in parallel, connecting power that goes all around above the windshield to this side, where I'm gonna have a switch that goes for a light that's above the loft here, that's above the driver area. And as well, I'm also daisy chaining, connecting in parallel the power that's gonna go to the camera that's gonna be on this side. So it's gonna be close to the switch for the lights. I'm gonna tap into that power. All right, let me show you what I'm doing now. I am done wiring, I'm done installing the wires for DC, and now I'm using these cable ties. There are 8-inch cable ties. They have a hole for a screw here, and I'm using these drywall screws to hold these wires to the framing, and I'm basically installing it between these between the studs, because the stud itself was gonna serve as a to hold the cable. So I'm gonna have about every 12 inches basically supports for the cables. It's looking good so far, as you can see, and I'll show you how I'm. Alright, so over here I get all these bundle of wires for DC for various things. Okay. There we go. So that's nice there. And when I put, you know, shiplap wall here, that's gonna hold it further. That's looking good. Now I gotta do this next one over here. I have finished wiring the left side DC. This is how it looks like. I have more studs here because that's where the shower will be. And having like 24 inches on center or whatever the head channels are, it's too wide, so I added some between. That black one is just for the backup camera, and its connector at the end is like half an inch or more wide, and I couldn't find my hole saw to drill through this framing here, so I kind of just notched it over here. And you know, that's how it's gonna go. Now what I have to do is start doing the AC wiring. I do have few DC that I need to do, but that's gonna be going through the dividing walls and a few things in the ceiling just for the light there from one light to the other. But I'll do that as I'm installing the ceiling, the shiplap or whatever we put on the ceiling. But most of the DC is done. So I switched to AC, and I have the 12 gauge marine grade wire again, with three wires inside. Here it is, I got 3 12 gauge, the same brand, Anchor brand of wire. So it's 12-3. On the left side of the bus, I'm gonna have one circuit that's gonna have a outlet in the bathroom, outlet in the kitchen above the kitchen counter, outlet behind the stove, and then outlet above the couch on the left. So it's gonna have 4 outlets on one circuit. The stove is propane, but it needs for the light and for the igniter, it needs the AC, so it's not gonna draw a lot of current. All right. Now it's time to install the electrical boxes for switches and outlets. I already did a few of them, and I'm gonna show you how I'm doing 1 or 2 of them. I got 2 types of electrical boxes, and I'm gonna show you these are the boxes, and I'll put on the screen their part numbers and links in the description. These are shallow boxes. They're 1.5 inches deep, so that will fit the framing that I have, which the studs wood framing is 1.5 inches. And for this one, I also have a mud ring up on the front. This mud ring, so I get 1/2 inch sticking out because I'm gonna make it flush with the stud, and then this is gonna be 1/2 inch sticking out because the shiplap we put is gonna be 1/2 inch thick. This one already has a marking over here for 1/2 inch, a 1/4 inch and 1/2 inch. So it's gonna stick past the framing 1/2 inch. And I got this one. This is gonna be used for light when there's a single light switch or once single like outlet, power outlet. And I got this one because it's got an extra storage space. So it's a wider one, so the wire, I can tuck in the wires because it's shallow, right? So I need more, I wanted more space there. They sell the ones that are like only this big, but I didn't know if it's gonna have enough room for all the wires, so I just got this big one. I have room in the wall to put it. This one I'm gonna use for I already installed it. I showed you over there for the 2 light switches. They're both DC. One is for the outside light, one is for the inside light. And that's why I got this one. Now you have DC and AC next to each other. Like I have one location in the kitchen, I'm gonna have a light switch for DC and a power outlet for AC. You cannot use the same box for both DC and AC unless the box has a divider between them. Okay, just to let you know. So if you buy a double gang box, you cannot put AC and DC unless they have a divider already between them. Which means I'm gonna have to do 2 separate ones. I'm gonna have one of these for the DC light switch, and then next to it for the AC electrical outlet, another one. Because I couldn't find the shallow boxes that have a divider. So I can put the same DC and AC in the same one, just so you know. Over here I have an oscillating tool with this little blade, flat blade, so it helps me get this foam. I have to remove some of this foam over here so I can fit the electrical box. Here it is, it's done, and the box can fit there, and I can get it spaced out 1/2 inch. There's a mark there, as I mentioned, 1/2 inch from the stud. A clamp with me, that way I can get it clamped while I'm hammering it. So let me line this up here. Okay, so if you can't reach the nail with a hammer, you can get some kind of an extender like this for a socket wrench and put it on the nail, and then you can hammer. That's beautiful. And I got one more left. There we go. So now that's 1/2 inch off the stud. It's solid. That's not going anywhere. This can fold over and close once I run the wires there, but yeah, this would close. Now I just need to push this here so I can run the wire through. This serves as also like a clip that holds the wire so it doesn't come out. So don't knock this out, this plastic clips there. They should stay in there. All right, I got my wire here. I'm gonna fish it through, let's see. There we go. I'm gonna just screw this wire in. There we go. That's good. Right now I'm going to show you how I'm installing this second type of the box. This one is a double gang, and this one goes flush with a stud because I have a mud ring that goes on top to space out one side the thickness of the wall. This switch is going to be two switches. One's DC. One switch is going to be for the fan that goes to the inside the composting toilet in case we need to turn it off ever. The other switch is going to be for the water level sensor in the gray tank, because I don't need it to draw current constantly, show me constantly the level of the water. I want to be able to flip the switch and then show me the level when I want to turn it off and don't need it the rest of the time. So I just got some of these screws. This one a little bit sticking out. I messed up there. I should have used the smaller screws. These are a little big. So these screws are thinner, so I'm gonna put them. I'll add one of each. I mean, one on both sides. There we go. And these are better for this job. Thinner. Okay, that's good. And here's the mud ring. So that mud ring is gonna come over here. And you wanna put these curved hooks are laying on the screws, like in this one in the corner. Okay, I'll adjust that later. But basically the hole in the final wall will be cut out here, and this has holes for the plates for the switches. One plate, I mean, but two switches. There we go. Now for these guys over here, you're gonna need to add the little clips that retain the cables in, because they're just holes here. Whereas these ones, they have built-in little clips that hold, so the wire can't get pulled out. But these ones don't have, because these are meant for the plastic conduit. But I'm not putting a plastic conduit, so I'm not buying those fittings. So you can just buy the right size ones that are they push in here, and they have built-in little one-way kind of like a clip that kind of holds the cable. This is it. These are bigger ones, and these gray ones are the smaller ones. And I took one of the bigger ones, and I'm gonna just put it in here. There we go. And then now I can put these guys in. And then one more. I think you're allowed to do 2 per hole. There we go. Gotta add some more over there. Alright, the wiring roughing is done. It's almost done. There are a few odds and ends I need to do, but most of it is done. I just have like a 1 or 2 outlets up front, 1 outlet and 1 switch in the loft area, and then once we add the dividing walls, I have some switches and outlets to add in those. Oh, another thing I need to do is the shore power hookup. I'm going to have a separate video for that, and I can do that later on. And when I'm putting the lights in the ceiling, I'm going to tape with some heavy duty tape the wires to the shiplap, you know, it doesn't go moving around when it vibrates. But let me show you what I've done. So over here we have all these wires coming in. That's where I'm going to have the inverter, the batteries, and all that solar equipment is going to be there in that corner. There's going to be a dividing wall over here that divide this small garage in the back from our bedroom, master bedroom. So all these wires are going to go into that wall, and then you're going to hook up over here to the batteries and everything else. That's on the right side of the bus. So we have DC and AC wires running here, 12 volt, 24 volt, and DC and AC 120 volt. Over here there's going to be another dividing wall. That's where our bedroom ends, and then the bunk beds begin here. In that wall we're going to have all these wires coming in, and they're going to be switches here. On the other side, switches for the bunk lights. On this side, switches for the bed lift, the solar panel slide out actuator, light switches. So they're going to be on the inside of our bedroom. So I kind of have that wall is going to be all like a junction point where we're going to be connecting, because a lot of these wires are going to be connected in parallel, so they would come up to here and then go on further up front. That's why I have all these wires here terminating. Then we have over here a outlet, power outlet for the lower bunk bed, and then goes up here, power outlet for the upper bunk bed. And then the lights for the upper bunk bed, I'm gonna add that in this wall that I add. I'm gonna add the wires for the upper bunk bed here in the ceiling. So yeah, well, once I build that out, once I start putting the ceiling, I'm gonna run those wires there. Then it goes up here. Now this is the 12 volt DC for the vent fan, so that's gonna go up there and hook up to the vent fan. Over here we're continuing. We have a power outlet for a fridge, and then a power outlet for the microwave on top of the fridge. Yes, we will have a microwave, because that's one thing I couldn't be without, because it's so convenient and fast to heat up the food. Then we have coming up here, this over here is these 2 lines. One is the okay, so one goes to the hallway lights. So there are going to be 2 zones of lights basically, first half and second half. And this one is light switch, 24 volt couch kitchen. Oh, so this other one goes to the lights in the first half of the bus. So one is for the lights in the second, one is for the lights in the first. Then we come over here, we have, this is for the AC outlet above the countertop, and this is the switch for the hallway lights to turn on and off the hallway lights over there, that second half of the bus. Then it keeps going up here. This is a power outlet above the couches or dinette. We haven't decided what yet we're gonna do, but there's gonna be power outlet there. and these wires go around, and then this is two switches here. One is for the outside light, one is for the first half of the bus lights here in the kitchen and the dining area. So these wires go up here. This is for, one is for that outside light. Outside light's gonna be up in the corner there. And then this is the second one is the power that goes to the surveillance cameras that we're gonna have on the right side here. One camera there, then it kind of continues. One surveillance camera in the middle, then goes on the left side of the bus in the corner, another surveillance camera. And I'm tapping into that power as well for a light in the loft. I'm gonna have two lights on both sides of the loft, and there's gonna be a switch over here which I have to still install. So that's all gonna be in parallel connected with the cameras on the same circuit. On the left side of the bus, we come out here because we're gonna have that dividing wall here. So this is it goes across and it's gonna connect into the battery, but some of the stuff is gonna connect into the, here we're gonna have the water heater coming in from the outside, Harvey water heater. So there's a cable that goes there. There's also a water pump over here. It's gonna be somewhere over here. So I have two lines going into those to be switches. They go all the way up front, where I'll be able to turn the water heater on and off, as well as the water pump from up front in the kitchen. That's why I have two lines there. This black line is the backup camera. Then we have a power line, a DC of 12 volt for the fan for the composting toilet, as well as power for the gray water tank. Gray water tank is going to be more up front, between the front and rear tires on the left side. So we need power for that sensor there, the level sensor, water level sensor, the gray tank. And I'm gonna put the sensor in the bathroom near the toilet. There's gonna be a sensor there. So these two, one of them is a 120 AC outlet. This is two switches. One switch DC, one switch is for the fan, if I want to ever turn off the fan for the composting toilet, and the other switch will be for the water level sensor, the gray water tank water level sensor, because I don't need it to draw power all constantly. I just want to be able to turn it on, tell me the level, and then I can turn it off. Save some power there. And then over here we continue. These are where the one of the lines is for the fan power, one is for the sensor that's gonna go down into drill through into the tank, and then we have water heater switch and the switch for the switch for the water pump, which I have not gotten those switches. I'm not going to use the regular switches, the big switches that take a lot of space. I'm just going to get small, like one of those like button switches, and put those in the wall. This is a power outlet, 120 volt for above the kitchen counter. Then it to the same one connects over here. This is for the stove. Stove is propane, but it needs the 120 volts to power the light and the igniter. So that goes there, and then to it's connected over here, another power outlet for the above the couch or the dinette, whatever we decide to put here, 120 volts. And I might run another line all the way up there, so we have a power outlet in the loft as well. I could hook up to the DC and have like a DC to USB converter and just have a USB plug there. But I might just do another run over here to get 120 up there in the loft. Over here, I also forgot to mention we have a microwave that's on a separate circuit from fridge is on its own circuit, microwave it's on its own circuit, but also into microwave I have another cable going down that's gonna go down into a power outlet. We're gonna have storage box there. I'm gonna put a power outlet for outside, inside of the storage box most likely. So this cable goes all the way there. This is above the fuel tank. I'm gonna install that all the way in the front. We have a small area where I can put a small storage box, and I'm gonna have a power outlet in there. So we can have like 20 amps outside if we need to run 20 amp circuit. And I put the fridge on its own circuit because that way I don't need to use a GFCI outlet because it's on its own circuit, because GFCI outlets can have issues. They can get tripped by fridges. So that's why I'm doing that. As I mentioned previously, I put 12 gauge wire everywhere, DC and AC. And I use two types of electrical boxes. This one, these are shallow boxes. They're 1.5 inches deep, but they have this expansion on the side to have enough room for all for the wires. And I'm putting that one 1/2 inch off the framing because I'm gonna have shiplap there that's 1/2 inch wide. And the other type is this one that has two. It's a 2-gang. That one gets installed flush with the framing, and then you have this mud ring in the front that sticks it out, so that way when you add the wall, it sits flush. And this one will be for switches, the DC switches. Two switches here, and I have two in the front for the outside and inside lights. So any other tips here? When you're using these ones with the two gang, these are also shallow 1.5 inch. You also need to buy these clips. You see this black ring here? You shouldn't be just putting the wires in the hole. You need these. These are retaining clips. Basically, they prevent it from coming out. Another key things to do is when you are installing, when you're connecting these wires, try to get them about every 12 inches with fasteners to the framing. And I use these cable ties that have a hole for a screw. And also important is, I think, coming out of the electrical box, you want the for a cable tie to be close to the box. There is like 8 or 12 inches you have to do at least. You can't have more than that. I'm not sure exactly the rule, but I'm doing it very close, much less than that, just to be safe. So this is all keeping it solid. It's not gonna come out. These are all nails here that hold these, and they're solid. I don't think they're gonna be coming out at all. Yeah. And then for the ceiling, so I cut grooves into the framing so I can put the wires there, because I'm gonna be connecting lights, and then I gotta run another cable wire to the next light. I have puck lights that I bought 24 volt lights. They run on 24 volts, so that will save some power there. I don't need to be running it through a inverter. I don't need to run 120 volts like a regular house. I have DC lights, LED lights. They're not going to be dimmable because the driver that came with the lights, the drivers, each light has its own LED driver. They're not dimmable. So, and I really couldn't find a 24 volt DC input, 24 volt DC output dimmable driver. I can't find those. They're all 120 volts input and 24 volt outputs, the dimmable ones. So lights are not going to be dimmable. But yeah, as I'm putting the shiplap in the ceiling, I'm going to be adding these wires to the lights and taping them with heavy duty tape to the back side of the shiplap, and that way they stay in place. But right now, half of them are on the floor, and a few of them are just hanging up there because they got stuck into the grooves. But yeah, that's basically it. Bedroom. the switches for the lights in the bathroom here, they're gonna be in this dividing wall that I add. So I'm gonna run those wires once I add the dividing walls. And I'm actually gonna be raising the floor in the bathroom to run all the plumbing under. So I can also run those wires down and under the floor, under that raised floor, up to this dividing wall. So I have the light switches in the bathroom there. And the diesel heater is going to be in the back in the storage room, so I can install that later because I'm going to have access there. I can drill holes and run the wires, and I don't need to worry about control panel for the diesel switch being anywhere up front. It's just going to be up here in the back. Another thing to add is that it's good to put plates here to protect your wiring, so you don't accidentally drill through the wiring with a screw or something. I might add that, or I might just try to be very careful when I'm installing the walls and everything, so I don't accidentally damage the wire. I was initially worried about DC and AC wires being close to each other and causing interference and whatnot, but I found a section in NEC that said if they're rated for the same voltage, they should be fine. They can be run in the same conduit. So these are sheeted really well and marine grade, and they are DC and AC all rated for the same voltage, so should be fine. Hopefully I don't have any issues with them running next to each other, because I read something that one can induce current in the other. If you wonder how much wire did I use for this project, I used almost 450 feet of 12-2 wire, the DC, and 200 feet of 12-3 wire for AC. I actually need a little bit more for AC for a few things in the back, so maybe 220 feet, something like that. That's a lot of wire, but I kind of overdid it because I have so many circuits. But yeah, that's it. All right, let me know what you guys think. Is this looking good to you? Do you have any other tips, suggestions? But yeah, next thing is I gotta go buy some shiplap and then start installing that. I'm excited for that because it's finally gonna start looking more like a house, you know, seeing some serious progress.